Another question that we want to solve using the techniques we've learned for simplifying systems of linear equations. It says I have 32 bills in my wallet in the denominations of $1, $5, and $10. $1 bills, $5 bills, and $10 bills. And the total is worth $100. And the question is, how many do I have of each denomination? So, as usual, we can say um, let x be the number of $1 bills, and then let y be the number of $5 bills, and let z be the number of $10 bills. Then an, an easy equation we can write is that x plus y plus z equals 32. But then, because the total value of the bills we have is $100, we know that if we multiply um, the number of $1 bills we have by the value of $1, so we have x of that, that's 1x, plus the value of the $5 bills will be 5y, plus the value of the $10 bills is 10z, and this is also equal to 100. So these are the two equations we have. We can label them as equation 1 and equation 2. And what we would really have liked is to have had a third equation, but we don't. So what we do, we can eliminate one of the variables. Let's say we eliminate x. If we eliminate x from equation 2, so let's subtract equation 1 from equation 2. So equation 2 minus 1 gives us 4y plus 9z equals 68. Okay, so gives us a relationship between y and z. What we can do, let's call this equation 3. One thing we can do is just to pick some values for z and see how plausible those values are. So for instance, can we have z equals 0? What happens, let's say, what happens when z equals 0? When z equals 0 from equation 3, we have 4y plus 9z, which is 0, equals 68. That means that 4y equals 68. So y equals 17. And if y equals 17, then from equation 1, what can we say about x? From equation 1, because z is 0, we have x plus 17 plus 0 equals 32. So that gives us x equals 15. So choosing z equals 0, we get y equals 17 and x equals 15. And let's check what the total value of that will be. If you have 17 $5 bills, that's going to give you 17 times 5, which is 85. And if you have 15 $1 bills, that's 15. And 85 plus 15 is indeed $100. The only problem with this solution is that it gives us z equals 0. And that is a problem because it says that the bills in my wallet are in the denominations of 1, 5, and 10. That suggests that we have at least one of each bill. So let's see if there's another value of z that is also going to give us values for x and y, that will still give us a total value of $100. Um, we can try again with, let's say, z equals 1. So what happens when z equals 1? When z equals 1, we have, because 4y plus 9z equals 68, we have 4y plus 9 equals 68. That means that 4y equals 59. Now, this is not helpful because we want an integer value for y, and 59 is not a multiple of 4. So z equals 1 is out. What about z equals 2? When z equals 2, we have 4y plus 9z. So 4y plus 9z is 18 equals 68. That means that 4y equals 50. But here again, 50 is not a multiple of 4. So we cannot solve this. When we solve this, we're not going to get an integer value for y. So we cannot use z equals 2. Um, we can try again with z equals 3. Uh, if you try with z equals 3, you're going to get 9 here, 27. So 68 minus 27, that's going to give you 41. Again, that's not a multiple of 4. So whatever value of z we pick, when we simplify, we must get a multiple of 4, so that when we solve 4y equals that number, we're going to get an integer value for y. So z equals 3 is not working. Z equals 4 gives us, let me write that, z equals 4 gives us 4y plus 9z is going to be 36. 36 equals 68. So 4y equals 32. So y equals 8. So when z equals 4, we get y equals 8. And we can find the corresponding value for x. Because x plus y plus z is 32, if you have z equals 4 and y is 8, the total is 12. So you're left with 20. That gives you x equals 20. So this says that when you have 20 $1 bills and 8 $5 bills and 4 $10 bills, you're going to have a total of $100. Let's see. So x 20. So 20 times 1, that's $20. Um, then 8 times 5, that's $40. And then z equals 4, that's 4 times 10, is also $40. So 40, 40, 20, yes, that's $100. So that gives us a solution. 20 $1 bills, 8 $5 bills, and 4 $10 bills. We could try with different values of z. Z equals 5, but again, using the same principle that we want a multiple of 4 at the end of simplification, we know that z equals 5 is not going to work because 5 times 9 is 45, and subtracting from 68 gives us 23. So z equals 5 doesn't work. Z equals 6. 6 9 is 54. We subtract from 68. That's 14. It's not a multiple of 4. Z equals 7. That gives 7 9 63. We subtract from 68. We get a 5. It's not a multiple of 4. Z equals 8. That's 72. That one is completely out because when you have 4y plus, we are using z equals 8. So let me just write it out. 9 times 8 equals 68. Now 4y, 9 times 8 is 72 equals 68. Now This gives 4y equals 68 minus 72, which is minus 4. So this one is completely out because we cannot get a negative number. And we cannot use z equals 9 or z equals 10 because that'll give us even more negative numbers. So this is indeed our solution. Our solution um, is z equals 4, y equals 8, and x equals 20. That means that we have $21 bills, 8 $5 bills, and 4 $10 bills. And that's the unique solution if you want to have at least one of each bill in our wallet. Interesting problem.